Hello, class. Today, let me go to the last room. We are going to be presenting human accountability and ethical governance in artificial intelligence. My name is Trey Williams. I'm a doctoral candidate for the University of the Cumberlands. This class is MSAI 633, Ethics in Artificial Intelligence, taught by Dr. Zahid Malik. And today is August 15th, but this is due August 16th. All right, so to begin with, we must discuss why AI ethics matters. An AI model can be statistically accurate, but at the same time still be unethical. AI, of course, is increasingly used across many industries, to include healthcare, education, security, business, and organizational decision making. It is also used in military, as we will discuss later. The AI provides significant benefits, but may also create risks. These risks include privacy, bias, transparency, security, accountability, and human control. We will go over these in granular detail later, so I'm going to move on. So, for AI ethics, the ethical concern may extend beyond whether an AI model is technically accurate. I've seen this many times with the use of the labs throughout the course. We will, while the AI is correct, it may not be what would be considered ethical. This was much more prevalent during Chat 3.5, moving onward. They've since put a lot more guardrails on it. Um, Therefore, the larger question is whether AI decisions and consequences are morally and socially acceptable. You don't want models that are making decisions without human interaction or control. You also don't want the AI to just jump ahead and do things. We see this a lot with AI weapon systems where the kill chain consists of only model inputs. We don't want that. We still want the individual there pulling the trigger. So the central argument of this research paper that I created was autonomous AI can create an accountability gap. Humans must be there to design, approve, deploy, and use the AI systems. The responsibility cannot simply be transferred to an algorithm. And then the responsible AI requires human accountability, ethics throughout the system lifecycle, transparency, bias, and harm assessment, as well as ethical education and then governance for high risk applications. To start this discussion, we must discuss the ethical foundations of AI. So the ethical foundations of AI consists of ethics of AI as well as ethical AI. Ethics of AI consists of principles, policies, laws, rules, and standards that are governing AI. This is really the governing framework that we must use to adhere the AI to the standards of governance that we will be trying to adhere it to. You see these a lot with the new guardrails, the new ethical design. You also see this with the new AI models restricting the ability to change how children's pictures get edited, stuff like that, where it wants to change the governance overarching of the AI. Ethical AI, on the other hand, is how AI systems themselves behave and make decisions. This is done during the planning, development, and then modeling and testing phase of AI. We can use good AI architects. We can use ethics with a ethical AI to better move these models so that we don't have to worry once they're deployed that they are not making these decisions. So some core ethical principles include fairness, accountability, transparency, privacy and security, benefits, benefit, ah, words, beneficence, human autonomy, and then prevention of harm. These are very important. You want the AI to be fair whenever it's deciding on where it pulls data from, as well as accountable. You want to be able to see the backwards tracing of how it's doing what it's doing. That leads directly to transparency. You want the AI to be able to show how its thought process works when it was developing the answer. This is kind of hard with black box models, but they're becoming more and more transparent because you're using one AI to show the transparency of another AI. You also want to have privacy and security within the AI model. You don't want them to breach containment. Um, excuse me, breach containment or their own security protocols. You don't want one AI to move into and cause a cybersecurity threat to another AI or another database and then penetrate it. You don't want that to happen. Benefin, I cannot pronounce that word. Benevolence, benevolence. Ah, you want it to be benevolent. Um, I'm sorry, I can't pronounce words. The dyslexia is getting me. So you want them to be good for the sake of good. You don't want them to do things that are harmful in nature to people or to working with when they interact with databases and causing issues. You also want them to be able to cite what sources they have so that they can give proper credit that way, and that they are not just whole hawk creating new sources. We used to see that a lot. It's not so much the case anymore because most of the guardrails fix that, which was one of the labs in this course. Next, we go on to human anatomy or autonomy. Humans must be able to make their own decisions. You don't want like the thing of scammers being able to influence people using AI voices or AI videos. You want to be able to make sure that the people are able to understand that. And then, like I was saying, prevention of harm. You don't want the AI to be used by certain individuals to make them have harm. You don't want. I think the best example I've ever seen of this is AI's use in Social Security. You don't want it to cause like people who are alive and receiving benefits to for the AI to just destroy their access to those benefits because the AI makes a determination on their ability to have the benefits, something like that. These ethical principles may conflict and require human judgment. With a lot of the stuff that I see, I don't like how AI writes personally. So I have to, even when I do work with it, I have to go in and edit it heavily. So it gets me to about 70% solution on things I do at work, but I still have to go in and make sure that the article or the references are correct and that it is spoken in the correct tone so that it works right. Newer models are getting that better than they used to, but I still don't like how it writes. Our editor at work hates AI writing and can tell it immediately. Um, so there's a lot of people who are able to see that, but they do change, so let's be aware of that. All right, so now there's ethics throughout the AI lifecycle. As Dignum's three-part framework, so there's ethics by design, ethics in design, and ethics for design. Ethics by design is build in ethical safeguards, guardrails, and constraints to the AI. This is done during the design, data, and development phase, as somewhat in testing, but not so much. And then there's ethics in design, which is evaluating ethical consequences during the development phase. This is part of testing. And then the ethics for design is to establish professional standards and codes of conduct. This is your overarching framework, your risk assessment or your governance framework that allows you to get to the point where you're deploying, monitoring, and then at what point you retire the models. Um, Models don't last very long right now. I don't even want to say 2 months before new models are introduced. So from a design perspective, you're constantly updating, designing, developing, testing, and deploying new models. The This risk assessment framework comes in when it's the monitoring and retirement. You want them to be monitored and then retired when they're no longer useful, and you want them to be expunged completely. You don't want like a freewheeling. It's the same thing with an old piece of compromised software in your stack. You want it to be useful, and then whenever it no longer is useful, to be expunged. Ethics and AI or ethics should influence AI from the requirements and data set selection through deployment, monitoring, and retirement. Like I was saying, I've had some issues whenever I build models for work with data sets. Many of the data sets I'm working with are very dirty, and then the cleansing, we have to have a testing framework to get good, clean data. And it's very challenging because there's a lot of reporting issues with the data sets. So we have to make sure at the same time we're ethical in how we're developing our data sets. And then once we get the testing done, that we've done a good job of parsing the data, make sure there's no multi-collinearities or anything like that. And then a bigger issue is providing synthetic data. I'm not currently allowed to use any synthetic data. All data must be real data whenever I develop my models. So I have to be able to go back and be able to verify all of them. That's where the ethics in design comes into play. All right, next is human machine integration. So human accountability is forefront in human machine integration. A human must be there as either the designer, trainer, deploying, or maintainer of the model. If there's no human in the loop and AIs are just making AIs, you're going to have a compounding issue of ethical concerns. So the responsibility may be distributed among, of course, the developers, data scientists, organizational leaders of your organization, as well as vendors of software suites and operators of those, as well as the policymakers and end users. At any point in that chain, you can have issues, ethical issues. A lot of the time, it's either the operators or the end users causing issues. In my dissertation class, I'm currently working on cybersecurity, AI integration of cybersecurity models to stop insider threats. This is a very parsed data set. There's almost no insider threats at all in it. So it's very challenging to get to that point. To combat this, you have to have good operators as well as good organizational leadership to stop the bad actors from coming in and causing issues. There's been a lot of issues with AI developed code from the developer standpoint of security issues with the code, just because when they prompt the code, they don't understand the framework that they need to implement to have good cybersecurity. So for the moving on, accountability becomes difficult when responsibility is distributed, but no stakeholder accepts ownership. This has been happening a lot with driving with AI-driven cars. I don't have a site for that, but it's tangentially. Who is responsible for the the vehicle when it's in AI mode? It is always the driver. The same thing whenever the AI models are distributed, who's responsible for the AI model? It is the developer. They cannot shirk that responsibility or that accountability. That's impossible. They will be held accountable for it. Next is the two critical factors of accountability are control and knowledge. So control is the operators, end users, policymakers, and then knowledge is the developers, data scientists, and the organizational leaders and the vendors. If they know that there is an issue with the product, it needs to be pulled and retired, and then a new product established. All right, so next is meaningful oversight. This is one of the bigger concerns with AI right now. When it first released, there was not a lot of oversight. Over time, it's been rapidly increasing. So we begin with simply placing a human in the decision process is not enough, especially with higher end large learning language models. They can influence a person very easily. So human operators need time to evaluate recommendations, relevant information, as well as authority to reject and modify AI outputs, and then training to identify the model errors. A lot of people don't know, like they won't research what the AI tells them. They'll just take it at face value and move on. Grok especially publishes a lot of false information because it works on preponderance of um, what's going on in Twitter or X. So that one, like stuff like that, where the model cannot be trusted to give good information, you have to be able to not take it at face value and go do the research on your own using actual um, research methodology. Whenever I use the UC archive AI, I always go in and verify that the articles that it's presenting me with are actually what it's um, that I want. I go in and read the article. I never just take it at face value. This leads to the human oversight becoming symbolic when operators automatically approve AI recommendations. I can see this happening with some of the like Google anti-gravity or um, I think it's ChatGPT Codex, and then a lot of people get messed up with the Anthropic coding. I don't even know what it's called, but they'll just whatever the AI wants to do to your computer is whatever the AI does to your computer. It will delete things you don't want it to delete, and you have to be able to control that and know what it's doing when it's messing with your computer. I prefer when I do coding like that to do it on my gaming laptop that has nothing saved on it, so if it deletes everything, I don't care. It's fine. But a lot of people use their personal family laptop with all the pictures on it and just delete everything to make room for stuff, and you don't want that to happen. So finally, accountability must be formally assigned and practically enforced. You have to have good operators, good framework to with it, cognizance of ethical AI to ensure that there's meaningful human oversight in your accountability. And all right, so next is bias, fairness, and transparency. AI systems learn from patterns of historical data. If you have bad data, you will have bad patterns. We have problems with this at work. We have to go in and do thorough data cleansing to make sure that the data we're using is good. There's an entire office of data that goes in and does that. And they're some of the best professionals we have. They know what they're doing. Overall, oh wait, bias can come from underrepresentation, historical discrimination, incorrect labeling, proxy variables, as well as modeling objectives. And the data set I use, incorrect labeling is rampant throughout because of how the database works. It's easier just to click one label than it is to click any of the other ones. And then there's only three labels that account for 80% of all of the data set, and that's almost impossible for how humans work. So we have to have a way to suss that out. Overall accuracy may hide poor performance of smaller populations. I've seen that as well. That's multicollinearity. You have to develop either larger data sets. I had got to the point where I had to develop a data set for one of my models that was over data for 4 years, and it was 100 megabytes large just to get large enough small populations to be statistically significant. This happens all the time in very, very niche categories, or if something's like there's not a lot of it going on. So next is healthcare AI might perform well overall while performing worse on vulnerable groups. That is survivorship bias. You don't want that to happen in your data set. Um, we have one where one job that I'm working on has a 70% loss rate for females, while the male is the statistical standard of 95. We don't know why that is occurring. We're trying to figure it out, and it's very trying for everyone. That has caused issues with the data set because if a female comes in and wants to do that job, the model will tell that individual no because there's such a high probability of them not completing the training. So that's something we need to work out internally. Next is transparency, privacy, and fairness. Organizations should be able to disclose the intended purpose of what they're doing, any limitations of the model, as well as the intended users and then the known risks. If you cannot articulate any of those, you do not need to release the model. Transparency does not require exposing every line of proprietary code of the model, just being able to show how the model works. This is becoming especially challenging with AI models. Like I said before, black box AIs are very notorious for not being able to describe this. Therefore, you have to use a different type of model, like TF transformer, an XGL boost. That's deep learning, but to just, or what is it, CCL, a category learning neural network can also show you why it's doing stuff. The stakeholders need enough information to be able to evaluate the consequential decisions. Me going into one of my executives' office and telling you this model works at 97%. Well, how does it work? I don't know. That's not an answer I can present. I have to be able to show how the model is doing what it's doing, either with an equation or with was it probability of success of the model of each individual factor. If I can't present that, they're not going to take yes for an answer and allow me to move on. They're going to kick it back. So privacy protection should address data collection, storage, use, and retention. If you're making proprietary models, you should be using an air-gapped computer. The model should not be able, especially, it must be in containment so it doesn't provide issues, especially if you're using a multi-agent that can jump through networks. You don't want that to happen and cause yourself to have that liability. Next is fairness criteria should be explicitly defined and tested across equivalent groups. You should be able to do a five cross, five, whatever, five-fold cross validation test of all models, and then check their AUC, something like that, some testing statistic to ensure that the model is working as expected. For stakeholders, there's ethical education and stakeholder participation. This is very important for any operational leadership position. You want to have technical competencies that do not automatically produce ethical competence. You may have really good coders who don't understand AI architecture. You may have really good AI architects who don't care and about the coders who do the front end, back end development for their model to fix it so it works with the users. So there's also AI ethical reflection scale identifies such things as ethical awareness, critical evaluation, and AI for good, for social good. For ethical awareness, you want to be able to be aware through, like I stated earlier, for all stages of development that the ethics were used. For critical evaluation, that's the testing phase. It should be able to be tested out, and there should not be issues unless they're intentional of that AI doing something that is nefarious, like going and stealing a bunch of money from a database of a bank. You don't want that to happen on your watch for your model. That would be really bad, and you won't want to be a part of that. As well as AI for social good. You want the AI to be ethical and have decision making. If it has issues that it kicks out, like really weird things, like the the sci-fi thing is kill all humans. You want it to be like the correct answer is kill all humans, but I don't think that's a good idea. You want the AI to be able to set that up for you so you don't have to deal with the consequences of that action. The AI should just be a tool for you to use that is able to do what you want, provide that decision support without making the decision for you. AI, AI literacy and ethical reflection are related but distinct. AI literacy is like how to do prompt engineering, stuff like that. Um, but ethical reflection is like, should I be doing this prompt? There's an interaction there. A lot of new users don't understand that those two things are separate and distinct, and they will just do whatever they want. So there needs to be like actual training for individuals. I believe the government's starting to do this, but we're still so in the infancy of mass usage of AI models that it's not occurring. Also, the next thing is developers and leaders should be trained to recognize ethical problems, not simply operate AI systems. They should be able to find the moral hazard. They should be able to find other issues with the AI for that perspective so that these problems don't compound and cause other issues. Stakeholders and other ethical foresight for the future. Developers may not recognize every possible effect of their product or model on patients, employees, students, vulnerable communities. They may not realize that a certain, like I was saying before, the multicollinearities that exist in the data are causing issues. You should be able to have that as a part of your data analysis and then be able to figure that out. But sometimes People don't care. They just data is data. Run it through. Don't worry about it. All data is training data. It doesn't matter like that. You must be able to have ethical foresight that that might become a problem. Stakeholders should participate before deployment. We have one model that we're about to deploy. It's been in the works for 2 years. It has been obsolete multiple times in that development cycle, and it hasn't even deployed yet. It doesn't deploy until October. It there have been multiple problems with it. This is a good thing though, because it has shown that the model is not ready and that more work needs to be done on it. There are ethical issues. There are user issues that must be reconciled prior to deployment. Um, you also need to red team and scenario-based exercises prior to doing this. Uh, During um, your testing phase, you need to have not only good data, but also synthetic data to provide any potential harms, any failure conditions, any unintended consequences, or different stakeholder perspectives. There must also be insider threat testing as well as penetration testing of the model or the data set to see what it does in that instance. The biggest thing we do is double factor authentication through the use of physical chipsets, which is really hard to do for um, external things to do, but it's not nothing is ever 100%, so you always have to be involved with that. Next is ethical testing can reveal problems that standard accuracy testing may miss. You might want to, I think the good one for this is prompt engineering standards. If a certain word comes up, the prompt won't work unless it's in a certain context. But then you have to have uh, natural language processing going on. So that could happen. Um, there may also be other things like user error of input of data into the model and then what it spits back out. That may become an ethical issue in the future. The next thing is high risk and weaponized AI. A lot of AIs are rapidly being weaponized. Uh, because most AIs are dual use. There was a story I saw about African um, militias using like an AI, almost radio operator kind of analogy of a man behind them using AI to um, facilitate their decision cycle for maneuver. That's a lieutenant's job, but they don't have the training or the skill to do it, so they're just asking the AI to do it for them. It does it, not well, but it works for them. So some other potential applications are autonomous vehicles and weapons. That's rapidly having the drones, the ground vehicles that are fully autonomous, including their weapon system that will auto track and auto engage if allowed. Surveillance, facial recognition, deepfakes, cyber attacks. Deepfakes are becoming a very strong issue. Uh, like I've made deepfakes of myself for fun that people, if they don't really know me, they think it's actually me. They can sometimes tell, they sometimes can't. There's issues with that. And then cyber attacks, you can use AI models to attack other AI models and then to override their programming. That does happen. It's not as prevalent yet, and there's already use to get around that. But this is becoming an issue. Continuing with weaponized AI, there's also technologies developed for beneficial purposes that can also be manipulated or weaponized. The use of images as well. You can use an AI to do radio frequency hopping, but at the same time, that algorithm can be penetrated by another AI and pull it out over the air. You can also use autonomous weapons to create unique ethical concerns. Um, the kill chain for an autonomous weapon is so much faster than a human. You see that in the movie, what was it, Aliens, where the it was shooting the target so fast that the humans couldn't keep up to know when it was shooting at the targets. That's something that's coming up rapidly. Uh, Whenever you're shooting one missile with another missile, all that's AI work with radars and everything, but it's really hard for a human to get in there and be able to function at the same level of reaction time as the autonomous system. So that's something to be of concern in the future. I think the one that was brought up in the book was the facial recognition software being not exactly perfect. If someone looks similar enough to another person and you don't have a person in the kill chain to look at the overlays of the pictures, you might have issues with them targeting the wrong individuals. That is a problem for people, so I don't know why it wouldn't be a problem for AI weapon systems. So how we get around that professionally is to have a board that does it, and then we vote on the board, and the board's responsible for the interaction. What really happens in conflict is that if there is not 100% certainty, they won't engage the target. We had that happen in Afghanistan a bunch of times. We couldn't tell if it was the real person with the satellite photo, or not satellite, the overwatching footage. So the decision was made not to engage the target. Having that built into the system does help um, avoid these mistakes. Moving on to responsible AI governance. Governance should span the entire life cycle, as stated before. We must also be high impact deployment, conduct impact and risk assessments, test models of independency, and then be able to identify affected stakeholders. Um, Something that's low risk should include documentation, basic monitoring, standard controls. Moderate risk is increased testing, human review, and then bias assessment. After the deployment, you can do continuous monitoring, monitoring changing operation conditions, and then maintaining mechanisms for human review. That's the high risk stuff. The independent testing, strict authorization, and meaningful human control. There will be a human in the loop for meaningful or for high risk things like weapon system deployment. Um, I don't even think like whenever the machine gun drones were coming out, they still wanted a person involved, even though it moved around by itself and could target. They wanted a person on the trigger to make sure the trigger was done correctly. That's a high risk from a government's perspective. So oversight should increase with the severity and to try to 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 stop irreversible ability from potential harm from occurring. The counter argument to the ethical AI is does ethical governance slow down innovation? This is the key issue. So stronger governance may increase development cost and time, as well as require additional testing and more documentation, which in the end slows deployment. From an AI architect perspective, I don't see a problem with this. If it's coming out and there's an issue and you publish it anyway, not care, you're going to have even higher costs, litigation, and consequential costs um, to your personality and your uh, person-to-person relationship pattern or relationships than you would if you had stopped it. Uh, Someone might be mad that you stopped the deployment and you missed a deadline. Oh well, if there was a known risk when it comes out and you knew about it and it was documented, you're going to be held liable for it. So it's better just to not do it. But not every AI system requires identical oversight. Like I was saying before, if it's a low risk issue, such as job selection at a job security place, and it's just giving you five jobs that you're going to be good at, like that's not high risk. That's maybe medium risk. It doesn't require the same amount of oversight that a AI facial recognition missile system from a drone would be. So the risk-based model allows for innovation while also imposing strong safeguards. You must do that. Any poor government may create like I was saying before, larger long-term financial, legal, and reputational costs. I forgot reputational word. Anyway, in conclusion, so the technical performance does not define ethical AI. While the AI may be accurate, maybe have a real high AUC, may have a good F1 score, it may be also unethical. For human, its response AI's responsibilities require human accountability as well as ethical design and deployment, as well as fair and biased assessment with meaningful transparency ethical education of your staff, as well as stakeholder participation in all aspects of development, as well as stronger controls for high risk applications. Autonomous operation does not make AI morally responsible. It is still the individuals who were responsible for the development, usage, and deployment of that AI, not the AI itself. It's just a dumb machine. It doesn't know any better. It's a big probability calculator. And then responsibility remains that humans and institutions that create, authorize, and deploy AI are always responsible for that AI. I'd like to thank everyone for their time. If there's any questions, let me know. Just put them in the chat. These are the references that I use throughout. I also, for the pictures, I put them on the individual slides. I didn't put them on here, but they are, I use mostly Army stuff because it's easy to pull those down for me. All right. Thank you for watching everything. Have a wonderful day. My name is Trey Williams, and I am an AI and machine learning doctoral candidate. Thank you.